Welcome back, and we're going to continue our discussion of function properties with talking about relative and absolute extreme values. Now, absolute value or absolute extreme values, they aren't in the textbook, but as long as we're at it, we might as well talk about them because you're going to see them eventually. Okay, but here's our favorite function from the last video, this W looking thing, and we talked about the intervals of increase, decrease, and constant last time at the very end of the video, right? So we said this, right? And my thing I want to think about is that, well, those boundary values are kind of interesting. So the ends of these intervals, right? So -1, 0, and 1. So if I look at those, that's right here. Oops, let's get a highlighter going. So we right there, and right there. Is there anything interesting that we can say about the function at that point? And maybe another way of asking that same question is, what do you notice at those values? What features the graph, or what features does the graph have at those values? And so that's what we're going to talk about today. The language that we use mathematically at these values is the language of extreme values, or extrema. That's just kind of the plural of it. So we would say that the f of a value, notice that this is f of a, so this is a y value. Okay, so we say the y value is a relative, and another term you could use instead of relative is local. So relative or local maximum if there exists a small interval around or near a such that f of a is larger than anything else near a. So think of it as a hill. Okay. Similarly, we would say that the y value at a, so again, this is a y value, is a relative or local minimum if there's a small region around there such that f of a is less than everything near it. And so this is, I think of this as a valley. So, and again, we're looking in a small region around it, not the entire thing. Okay, and notice that in the language, in the definitions here, we say that the relative min or max is whatever the y value is, and we say it occurs at an x value. Okay, we don't talk about the x value as being the maximum or minimum value. Okay, we just say it occurs there. Okay, and then just language, the plural of maximum and minimum are maxima and minima. And then when we talk about the collection of all maxima or minima, we talk about those as extreme values, or we can say extrema if we don't want to say extreme values. Okay, so then we want to go back now and talk about those the extreme values in our original example. So at -1, right, I see that, so when x is -1, right, the y value, this is -1 here, but we see that near that value, it's the lowest value in that region. So we would say that's going to be a minimum. Similarly, at x is equal to 0, the origin, we would say there's going to be a relative maximum because it's the highest value in that region. Again, the graph here, the thickness of the line might be misleading, but it's meant to be a hill there. And then we have another valley down here, so that's going to be a local minimum. So let's get the language going here. Okay, so I would say that we have a local, or I'm going to use local. If you want to use relative, that's fine. Local minimum of -1. Okay, that's the y value at x is equal to -1. And I just put the x in there just so I can understand. I can wrap this around my head a little bit easier so I know where the x's and where the y's go. I would also say there's a local minimum, minimum of -1 y value at x is equal to +1. And just to change up the language, I would say there's a relative, you can say local, maximum of 0 at x is equal to 0. Okay, so again, y value, we say it occurs at the x value. Okay. Now, as we look at the graph, we might say, well, these y values of -1 at plus and minus, or when at x is plus and minus 1, are actually the lowest values we're ever going to attain, right? Like, we don't go any lower. But we do go higher than, say, 0, right? And that value is a case in point. So the idea of lowest y value ever, that is the idea of, instead of relative, the idea of absolute. Okay, so we would say the y value is an absolute maximum if it's larger than all other x values. That's what this notation is saying. Similarly, we would say it's an absolute minimum if it's the smallest out of all the possible y values. Okay, so we would actually say these two here are absolute minima. Okay, so instead of local, you could, scratch that out and put absolute. Okay. If in this case it did say relative extrema, not absolute, or it didn't just say classify the extrema. So if you didn't have this absolute minima language, that would be okay. But to wrap this one up, I want you to pause the video and classify the extrema of this function picture below. So this one doesn't say local, so you should probably do local and absolute. Pause the video and try it out. And here are my answers. I have a local and absolute maximum at and I had to estimate here, so 1.7-ish at x is equal to -1, and then I also have a relative min, local min, of -9 at x is equal to 3. So that's the valley. Okay, so I have a peak and I have a valley, and actually according to this function, so we don't go past x is equal to 4, but we do, it looks like, go past x is equal to -3. So it would continue downward, so we don't have, in this case, we don't have an absolute minimum, but we do have these two. All right, so remember that you need to classify local or relative extreme values, or extrema, and if it doesn't specify relative, make sure to also think about the absolute extreme values.